So chapter 7 is going to be about similar polygons. And so we talked about similarity a little bit when we were doing ways of proving triangles congruent. And we talked about how if you just had angle measures, it wouldn't make the triangles congruent because the sides could be different lengths. And so they were similar because they're the same shape, but different sizes possibly. So that's kind of what we're leading up to, is talking about what makes polygons similar, and then specifically focusing on triangles. So that's kind of what's coming up. This is a kind of short chapter. We're going to do lesson 7.1 today and tomorrow. Tomorrow we'll be doing some more factoring and quadratic formula review. So a lot of algebra in this lesson and in this chapter. When you're talking about these two vocab words, these are words that students sometimes use interchangeably, but they're really not interchangeable. And that is ratio. Try that again. That is ratio and proportion. Okay, a ratio is a fraction. A ratio is a quotient. It says A over B where B is not 0. Remember that dividing by 0 is undefined, so that just means you can't have a denominator of 0 when you're talking about a ratio. Okay, and you're measuring the quantities in the same units. So that means when you have a simplified ratio, you should be able to say like 8 inches over 9 inches becomes 8 over 9, because the inches, you know, it's the same quantity. So it just becomes a number without a label. It doesn't matter to me whether you use the fraction form or the one with the colon. In different situations, it's kind of better to do it one way versus another, but they are interchangeable. We don't leave fractions inside of fractions or decimals inside of fractions. So that means that whenever you're writing a ratio, it needs to be in simplified form where there's no decimals or fractions and it cannot be reduced. Okay, a proportion is different than a ratio because a proportion is an equation. Okay, proportion is equation, and an equation that is comparing two ratios to each other. So proportion, equation. So that means it's got to have an equal sign, right? How do you solve a proportion? So when you have a proportion that looks like this, so let's say you have like x over 5 equals 10 over 9 or something. How do you solve a proportion like that?
Don't you have to cross multiply?
You just cross multiply. So when you cross multiply, remember that's going to give you another equation. So that would be like 9x equals 50 and x equals 50 over 9. I'm perfectly fine with you leaving answers in as improper fractions. If you want to turn that into a mixed number, you can. As far as fractions, shoot, I don't have a calculator open. Hold on a second. As far as fractions go, if you do 50 divided by 9, that's a repeating decimal. So I'm okay with you writing 5.5 repeating, but you should not round that to 5.6, okay? There really is no need to turn those into decimals. So kind of try to break your habit of wanting to turn fractions always into decimals. It is perfectly fine to leave it 50 over 9, just make sure it's reduced. Don't waste your time putting into a mixed number. Don't waste your time putting into a decimal. Some of them are not repeating decimals, so when you try to turn into a decimal, it's actually wrong, okay? But in general, you know, I think it's best for you to just leave it as whatever fraction you get, simplify it, and move on. Here we go. Okay, so when you see problems, you'll see a couple of these in your homework also. Find the ratio of the measures of the angles. Sorry, the ratio of the measures of the angles in this triangle is 2 to 3 to 4. So here's triangle NAP. Okay, and it's saying that the angle measures are in the ratio of 2 to 3 to 4. Actually, I'm not going to put letters on there because we don't really know which letter goes with which vertex. But you know, obviously the angle measures cannot be 2 degrees, 3 degrees, 4 degrees, because they're supposed to add up to how much?
180.
180.
Yeah, they're supposed to add up to 180, right? So it doesn't make sense that you would just add them up to equal 180 as they are. Like it cannot be 2, 3, and 4 degrees. So what we're looking for is because we want to keep the triangles proportional, the sides proportional and the angles proportional. So we're just looking for that common multiplier that we could scale up all those angles, those numbers by, in order to make them actually add up to 180. So we're just going to throw an x in there. 2x, 3x, and 4x is equal to 180. Okay, whatever x comes out to be, that's kind of like a common multiplier. So it's what you can multiply 2, 3, and 4 by to get the actual having them add up to 180. All right, so what is that? Let's see, 9x equals 180. Jerron, we're doing lesson 7-1. X is 20. Okay, have we answered the question? Did we?
You need to like multiply by 2 times 20, 3 times 20, 4 times 20.
Yeah, so to find the actual angle measures, we're going to need to actually go ahead and multiply by 2, would give us 40 degrees, by 3 will give us 60 degrees, and by 4 will give us 80 degrees. Okay, and we can double check by making sure it really does add up to 180. So always, in problems like this, always just do a quick check and make sure, yeah, 40, 60, and 80 adds up to 180, so that makes sense. These are not guess and check problems, okay? These are algebra problems. So your actual answer then would be 40 degrees, 60 degrees, and 80 degrees. Those are your answers. Okay, and then cross multiplying is actually also called cross products property. So they're going to say the product of the extremes equals the product of the means. I don't really care if you know which ones are which, but the means are actually the two values that are in the corners, like lower left and upper right, and the extremes are the other ones. It really does not matter to me if you know that terminology. Okay, what you do need to know is, again, ratios will never have zeros in the denominators. That's why it's saying B and D cannot be 0. But when you cross multiply that, it would give you A times D equals B times C. Okay, now make sure that when you're cross multiplying, you're going from an equation to an equation. Okay, I want to see that equal sign there. I don't want you to just do AD and BC and not have that equal. Okay, you got to have an equal sign for it to be an equation. All right, so solving. Braden, tell me how to solve that.
You would do t plus 4 times 3 and then 8 times t.
Okay, so I'm going to go ahead and write this way. What might be a mistake that you need to watch out for? This is for anybody. This doesn't have to be Braden. What would be a mistake you need to watch out for on this kind of problem?
Only multiplying it to like either the t or the 4 and not to both.
Yeah, usually what happens is we get the 3t, but sometimes we forget to distribute that 3 to the 4, right? So you don't have to write that step, but I'm just writing that there to remind you that you are going to have that 3 getting distributed. And then when we solve, 12 equals 5t, t equals 12 over 5. Gabe, we're doing lesson 7-1. Is Grace joining?
She should be. She not in?
No. A little bit rough this morning. Okay, how do you know? I don't know who that was. Started to ask.
How do you know what number is on top?
Oh, okay. So I'm kind of doing that in my head, but remember, you would be dividing both sides by 5. That's probably right. Just because we're starting this, it's been a while since we've done proportions. We haven't been doing a lot of equations lately. Okay, now again, I'm perfectly fine with you leaving it that way. If you want to put it into a mixed number, you can. On this one, if you wanted to do 12 divided by 5, see, that's exactly 2.4. Okay, it's 2 and 4/5. But there's really no reason to do that. Just leave it as, you know, the way that it was. Leave it as a simplified fraction. Every time I go away from notability, it takes forever. I'm going to not do that again. So Izzy, happy birthday. Are you 16? Are you 16?
Yeah.
Sweet 16. Okay. For the next one, it says write a proportion and solve. Okay. Brian is measuring plants in a field for a science project. Of the first 25 he measures, 15 of them are smaller than a foot in height. Okay. So if I make a ratio, I can say the number of total plants divided by the number, I'm just going to say short ones, okay? Instead of having to write out like the number of ones that are smaller than a foot in height, okay? So if we make a ratio of out of every 25 that he measures, 15 of them are short, what they're asking me to do is like scale that up, right? If instead of having 25 plants, if he has 4,000 plants, how many short ones should he expect to see? So our X is going in the denominator there. Now, are there other ways you could write that proportion? Well, you could do 15 over 25, but on the other side of the proportion, you'd have what? 15 over 25 would equal
X over 4,000.
over 4,000. Or, and you know, the way I compared it that way is because of how it was given in the problem. But if you wanted to say, I'm going to compare on the left side, the short ones, on the right side, the total, we could say there's 15 short ones in our like sample, basically. We're looking for how many in the, how many short ones in the total. And then there's 25, 15 goes with 25 and X goes with 4,000. All of those are equivalent proportions. So do you know how to look at that and tell that they're actually all the same, just written in a different way? That's what equivalent means. How do you know that all of those are actually like kind of going to work out the same?
They all have the same numbers.
Yeah, but like if I make that 25 over 15, it's not the same.
They
And
have to-
everyone each
It's when
number's
you-
being multiplied by the same.
Okay, Sam, you go ahead. There's too many of you trying to answer at once. I kind of missed.
Yeah, mine was kind of like, well, when you're cross multiplying, you're just multiplying all the same thing.
Exactly. That's how you tell that a ratio, or sorry, that a proportion is equivalent to another proportion. When you cross multiply, you get the same thing, right? So this is going to be 25 times X than the other numbers. This is going to be the other numbers multiplied equals 25X. So this one's going to be 25X equals the other numbers multiplied. They're all going to say the same thing. So that's why it doesn't matter how you set it up as long as you're consistent. So again, you wouldn't want to say 15 over 25 and 4,000 over X, because on this one, you're comparing the short to the total. So you got to do the same thing on the other side of the equation. So when you're setting it up, just make sure you're consistent. You either do short to total or total to short, or you do short on one side and total on the other in the, you know, the correct order. So just be careful how you set it up, but there are different proportions, you know, they look different, but they'll actually work out to be the same. Now you have two options. You can just cross multiply the way that it is, or you can simplify a little bit. What can you do on the left side? Someone who has not talked to me yet today. What can you do on the left side?
You could do 5 over 3.
Okay, so you're dividing out what?
The 5.
Yeah, you're taking out a common divisor, a common factor of 5. So 5 over 3 is 4,000 over 12, or sorry, over X. And then when we cross multiply, we just have smaller numbers to be working with. Okay, so we're going to have 5x equals 12,000. And then 12,000 divided by 5, 2,400. Now, if I put a label on that, what would the label be? Because with the word problem, you really should kind of have a label. 2,400 what?
Feet.
It's actually not feet. What did it ask you to find?
Plants.
Yeah, what kind of plants?
The smaller ones.
Yeah, total number of plants that are shorter than a foot. So 2,400 short plants. And the reason you know that is because that's what it asked you to find, right? It said find the total number of plants smaller than a foot in height. 2,400 plants smaller than 1 foot. Now, on the last problem that we did, the last word problem that we did up here, there's a label on that, right? Those are degrees. So, find the measures of the angles, the degrees is your label on that. Okay, in 2007, the ratio of births in Ohio compared to births in Indiana was approximately 5-3. There were 148,821 babies born in Ohio, and we're trying to figure out approximately how many Indiana babies would that correspond to. Okay, so Derbla, give me a proportion that we could use.
We could do 148,821 over
Okay, total number.
actually we could do
Well, that's okay. Use that.
okay, over 3.
Okay, so Ohio to Indiana is 5-3. That means that 3 corresponds to Indiana. Okay, you kind of have 2 options. You can either do total in Ohio to total in Indiana, or you can compare total in Indiana to like the ratio, or sorry, total in Ohio to the ratio number for Ohio. So you wouldn't be using 3, you'd be using what?
X.
So that's asking how many Indiana babies were, that's an option, right? So you could do total Ohio over the total in Indiana. And that's what you're solving for. Okay. Derbla, on the other side, what would that be?
5/3.
5/3. Okay, now somebody else give me a different proportion that also would work. Sorry, my 5s look weird today. So that would be a perfectly fine setup. Give me a different proportion that would work. Someone who has not answered a question today.
Could you start with like 5/3, or like 3/5 is equal to X over 148,821.
Sure. So that would be actually comparing Indiana to Ohio. On the left side, the kind of sample, right? And on the right side, the total. Okay, how about one more proportion? Someone, again, who has not answered a question today. Rylan, can you give me another way to set up that proportion?
Can you just flip the last equation there? Just 5/3 equals 1,400 148,821 over X.
That's like the same thing as the last one, just the sides switched, right? Okay.
Yeah.
What if I compared, what if I didn't use 5-3, but like I did something compared to 5 and something compared to 3? what would be in the numerators of those? This doesn't have to be Rylan, this can be anybody. What number goes?
Wouldn't X go on top of like 5 and then 148,821 would go on top of 3?
Okay, so let's check and see if when we cross multiply, we always get the same thing. So Diamond, when you cross multiply here, does that give you the same thing as this one?
I mean, shouldn't it? I don't know. You want me to actually do it?
But does it? So just look at, you don't have to actually give me the numbers. Just look at that cross product. Is that going to give us the same thing? Like, is it going to give us the same equation? Here, when you cross,
No.
you're going to get 5x equals whatever, right? And here you're going to get 3x equals whatever. So when you're setting up the proportion, you have to be careful where you put the numbers. So let's see what's wrong with this one. So when you compare x to 5, you're comparing, x would be the total number of Indiana babies over the total Ohio, no, not total, the sample of Ohio. But then on the other side, you have total Ohio over sample Indiana. So the problem is that you either have to have the total of both on one side and the sample on the other side in the correct, like they've got to match, the tops are the same, the bottoms are the same, or else if you're comparing total to sample, you got to have the same, like the same states matched up. Okay, so to fix that, you could say total Indiana to sample Ohio could be, let me see, hold on. I'm going to try to get proportions different than the other ones. But when you cross multiply, it should give you the same thing, right? So x over 5 is comparing, you know, I wouldn't even start x over 5. Let's start with x over 3. Okay, so if you do x over 3, you're comparing total Indiana to sample Indiana. And the right side should be what?
It should be 148,821 over 5.
Right. So again, when you cross multiply, that should make sense. And the reason it's making sense is because you're doing total Indiana over sample on the left and total Ohio over sample Ohio on the right. So equivalent proportions means you cross multiply, you get the same thing. So no matter how you set it up, if you have something that when you cross multiply, you get the same, then that means your proportion made sense. Okay, so 3 times 148,821 times 3 is 446,463 equals 5x. So again, I'm cross multiplying here. So I'm doing 5 times x equals the product of the other corners there. When you divide that by 5, you're getting, it divides to exactly 89,292.6. Okay, what's the label? What's the label?
Babies.
Okay, so what do you think about that answer?
Would it be babies in Indiana that were born?
Okay, so they're babies born in Indiana. Any thoughts about that answer?
Wouldn't you have to round out because you can't have just like 0.6 of a baby?
Okay, so we want to round it. And the question is, should we round up or should we round down? You're talking about babies. Does it make sense?
Round down.
Okay, so don't just kind of go, oh, point
So,
round up, right? You had a fraction of a baby. That means you really should be rounding down. So it doesn't really make sense to give that kind of answer in this context. So just kind of look at what you're answering. 292. And I'm going to write approximately. If you haven't seen that before, that's how you say approximately. I think in science, sometimes you might do like an equal sign with a dot over top of it or something. You'll see me use like 2 tildes like that. Baby's born in Indiana. Okay, so again, when you're looking at your proportion versus a proportion that I write, if they're different, but you cross multiply and get the same thing, that means your proportion's valid. Okay, so if you're like, well, I did something different, is this the same? You'll know that, right, by just cross multiplying and checking it. Okay, we're going to do some conversions. So those of you who are currently in chemistry, I'm going to do it how you probably do it in chemistry. And so these are kind of the ones that I'm expecting you to know, nothing too weird. This one sometimes is not one that comes to mind easily, but hopefully you got the centa and milli and kilo thing figured out. Okay, so these are ratios that are not considered simplified because you're comparing things that are not in the same units. So what we're going to do is multiply, but we want to multiply by a number that will not change the quantity that you have. So you know that if you multiply by 1, that won't change what the number is. It'll just change how it looks. Okay, so a reminder, when you're doing the multiplication, this thing you're multiplying by should be equal to 1. That means that you're looking for a comparison between meters and centimeters, right? Meters and centimeters. So 1 meter is 100 centimeters. And then since 1 meter equals 100 centimeters, you need to decide, are we putting meters on the top and centimeters on the bottom? Or are we putting centimeters on the top and meters on the bottom? How do you decide?
Isn't it centimeters on the top?
Why, Jerron?
Because when you cross multiply, you have to like multiply the same like units.
Okay, be careful saying cross multiply because cross multiply is something you do on proportions. Okay, this is cross multiplying. That's not what you mean here. Tell me what you mean. You don't mean you're going to do this, do you? Like,
No.
How do you multiply like 1/3 by 3/7?
We just multiply.
How?
Cross.
Okay, what do you mean by that? What is that? What is 1/3 times 3/7?
3/21.
3/21. You multiply the tops together, you multiply the bottoms together. Okay, so we're going straight across the top, straight across the bottom. That would be 3/21, which reduces down to 1/7. Now, sometimes you remember that you can simplify. I'm going to divide a 3 out, and that'll leave you with 1 and 1. But that's still not cross multiplying, right? That's just dividing out a common factor. 3 in the numerator, 3 in the denominator will divide out, would go straight to 1 to 7. But remember, when you're multiplying fractions, you multiply tops together, you multiply bottoms together. Okay, so just a reminder about how multiplying fractions works. That's what we're doing on this one, right? So Jerron said we want the centimeters to be on the top and the meters to be on the bottom. Now, again, this is supposed to equal 1. So I want to say there's 100 centimeters over 1 meter. That's equal to 1 because they're the same amount. Okay, a number divided by itself is equal to 1. Now, the purpose of putting centimeters on top and meters on the bottom is so that the units will cancel, right? This is like a 1 centimeter divided by a 1 centimeter and a 1 meter divided by a 1 meter. So the way you decide what you want on the top and what you want on the bottom is by looking at how it will cancel out the units. Okay, and then we're multiplying straight across. So just like on the fraction there, we're going straight across here. I'm not going to do any simplifying yet, just because I don't want too much going on here. But on the top, we'd have 500, and on the bottom, we'd have 250. And so that'll equal 2. And there should not be a label on this, okay, because we converted it using the, a common conversion there. That means the ratio is 2. When you compare the length of 5 meters to 250 centimeters, the ratio is 2, or 2 to what? If you had a denominator there, it would be what?
Is it 2 to 1?
2 to 1. So you can write it like that. You can write it like this, but I'm okay with you just saying 2. Okay, now if you had a 1 on the top, you can't ignore it, but a 1 on the bottom, you can kind of ignore. Okay. Anybody that feels like they can tell me how to do this one? I don't think I've talked to Izzy, Blair, Kara, Sadie, or Peter. Can somebody tell me what to do with this one? Ignore that 2 there.
Would you do 1 yard on top over 3 feet?
Okay, so we know we need to have yards on top and feet on the bottom in order for the units to cancel. And then, yeah, the equivalent or the conversion is 1 yard is 3 feet. Okay, if you think of a yardstick is approximately a meter, it's not, exactly, but the yardstick is like the bigger one, like the measuring stick that you might see like in a classroom. So since 3 feet is equal to 1 yard, then if we set it up like that, again, we're multiplying. This is not an equal sign here, it's a multiplication. So yards will cancel, feet will cancel, and then we can multiply it straight across. Straight across the top, straight across the bottom. So on the top, we've got 15 times 1 is 15. On the bottom, we have 12. Peter, simplify that for me. What can you divide out? Oops.
1 1/4.
Leave it as a fraction. Just tell me what you can divide out of 15 and 12.
3.
Okay, so that would give you 5/4, right? And it is 1 1/4 or 1.25. Again, I think it's easier on most of these problems to just leave it as an improper fraction. If this was a word problem, you might want to convert it into a decimal, but you need to be really careful that if you do a conversion that is a fraction, make sure you do not round on any of these problems unless it's like a word problem where rounding makes sense. Right. So if you put 1 1/4 or 1.25, that's fine. That's a correct answer for this. I would just say generally, it's just easier to leave it as a simplified fraction, whether it's improper or not, and then you don't, spend your time doing extra stuff that you don't still have to do. Okay, Izzy, tell me what the conversion is between inches and feet.
I'd say you put 3 feet on the top and then 36 inches on the bottom.
Okay, so what is the straight convert like?
Oh, you mean like 1 foot and 12 inches?
Yeah, 1 foot is equal to 12 inches. Okay, so you said put feet on the top, put inches on the bottom. Okay, so it'd be 1 foot over 12 inches. Okay, we multiply that across the top and across the bottom here. And again, our feet will cancel because we have feet on the bottom and feet on the top. And then our inches will cancel. And multiplying it straight across, we're going to have 15 over 24. Okay, Izzy, go ahead and simplify that for me. What can you divide out?
3.
Okay, so 5/8. I was writing that in blue before, wasn't I? Now, again, you can put that into a decimal, but there's really no reason to do that because you're just kind of wasting your time. Just simplify the fraction and go on. Okay, on this one, so we do have a conversion between kilometers and meters, but before you even do that, there's something else you can do on this one. What can you do before you even do the multiplying?
reduce.
Yeah, so we can go ahead and divide by 10. So that means you can cancel out a 0 there. Okay, those are just numbers. You can cancel out because when you multiply it across, you're going to still have that 0 that would drop out. So if you want to go ahead and do a little simplifying there, you can. Okay, Lily, I don't think I did talk to you, and I think I forgot to say your name earlier. Lily, tell me what the conversion is between kilometers and meters that we're using.
It's 1 kilometer equals 1,000 meters.
1 kilometer is 1,000 meters. So again, kilo means 1,000. Kilometers are kind of like miles, right? Like if you drive so many kilometers per hour, that is corresponding to like miles per hour. And of course, again, kilometers and miles are not the same distance, but they're kilometers are big, like miles are big. Okay, so 1,000 meters is 1 kilometer. So Lily, do you put kilometers on the top or the bottom?
The bottom.
Okay, so we want the kilometers to cancel, we want the meters to cancel, but again, we want to be multiplying by 1. So the purpose of putting 1,000 meters over 1 kilometer is that we're trying to eliminate the units, but we don't want to change what this amount is. We're multiplying by 1. And again, this is multiplication. This is not an equal sign. You're multiplying straight across the top and straight across the bottom. It's not a proportion. So that'll be 1,000 on the top. Again, our meters cancel, our kilometers cancel. On the bottom, you have 90. Okay, and again, the units should cancel. There's no label there. All right, how can you simplify that? Sadie, tell me how to simplify 1,000 over 90. Did I lose Sadie? We did lose Sadie. Okay. Grace. Oh, we also don't have Grace. Never mind. Let's see. Don't have Sarah. Talk to Lily. Okay, we're wrapping back around. All right. Derbla, tell me how you can simplify that.
You can divide by 10.
Okay, so dividing by 10 means that you're able to cancel a 0, right? That's dividing out a 10, so that would give you 100 over 9. Now, if you did 100 divided by 9, that would be a repeating decimal. So again, if you wanted to write 11.1 repeating, that'd be okay, but don't write 11.1. Sometimes these are not repeating decimals, and so you really do want to leave it as a fraction. But if you decide you want to write it as a decimal, even if you decide to do 1,000 over 90, it's 1.1 repeating. All right. Equivalent proportions. So this is what we were talking about up above. Equivalent proportions means that when you cross multiply, you'll get the same thing. Equivalent proportions just simply means cross multiplying gives the same equation. Okay, so I want to write some equivalent proportions to A over B equals C over D. So when you cross multiply here, when you cross multiply here, you're getting A times D equals B times C. So tell me what should go on this side. If I write B over A, what should go on the other side so when we cross multiply, we get the same amount. We get the same equation.
Should be DC.
B over C?
Yeah.
Okay, so in cross multiply, we get B times C equals A times D, or A times D equals B times C. So notice, what can we do? So let's look back up at that equation. What did we do to this proportion to get this proportion? Like, what's kind of the rule there? We turned A over B into B over A by doing what? How can you morph the first equation into the second equation? You had A over B equals C over D. What did they do? How did they turn it into the second proportion?
It's like flipped.
Just flipped. Yep. So cross multiplying gives you the same thing. And one way that you can create a new proportion from an old one is by flipping both sides. Okay, you were allowed to flip both sides of a proportion. Okay, how about the next one? In order to get the same cross product, A over C equals what? What does that need to be to give you A equals BC?
Would it be B over D?
A over D. So when cross multiply, we get A times D equals, and again, it doesn't really matter if it's C times B or B times C, and it doesn't matter if we put AD on the left or AD on the right. Okay, and so how do we go from the first proportion to the second one? So what do they do? Like, what can you do that first proportion to make it look like the second one? This is kind of what we were doing with that plant problem up above. So these are basically like rules about proportions. One rule is that you can take a proportion and flip the two sides and it'll still be a valid proportion. Okay, this one is saying if you compare the tops of the proportion, the numerators of the proportion to each other. So instead of saying A over B and C over D, if you compare A to C, that's okay as long as you compare the denominators in the same order, B to D. Okay, so this one is saying the ratio of the numerators is equal to the ratio of the bottoms. So if you had a proportion like x over 8 equals 10 over 3, you can call that x over 10 equals what? X over 10 equals, what would be equivalent?
Three over 8.
So when I cross multiply that, do I get the same thing? This is 3x equals 80, and this is 8x equals 30. Okay, so when you can,
No, it should be 8 over 3.
8 over 3. When you compare, if you go x to 10, you have to go in the same order on the bottom, 8 to 3. That's the only way that you're going to get the cross products being the same. Okay, so again, we go back up to like this plant one, 15 to 25, no, not that one. Not that one. This one. Okay, when you compare like on here, when you compare 5 to 1, yeah, that's this one, from this one to this one. When you compare 5 to 148,821, that's like this. Then you've got to be comparing 3 to x, which is that. But the cross product should be the same. Okay, and then if we're trying to get A over AD equals BC, what should go in the last spot there? What should go in this, on this side? We're trying to get AD equals BC.
D over B.
D over B. So let's cross multiply and check. So cross multiply, C times B equals A times D. And again, that's equivalent. We're just flipping the two sides around, right? Same thing. Okay, now C over A, you're still comparing the tops. It's just going the other direction, right? You're still going C to A. So you're still comparing numerators, you're just going left this time, and then D to B. So it's kind of the same thing as that one, is just sort of going the other direction. Okay, but the idea of equivalent proportions is whenever you cross multiply, you're gonna get the same equation. All right, 2 last problems here. The measure of the angles in a quadrilateral and the extended ratio of 3 to 4 to 5 to 6. I didn't really say this on that last triangle problem, but what that means is that you can say that 2 of the angles are in a 3 to 4 ratio. Another 2 of the angles are in a 4 to 5. You compare a 3 to a 5. You could say this one is half of that one. Like it's really taking a whole bunch of different ratios and putting them together. So that means 3 is to 4, and 4 is to 5, and 5 is to 6, and 3 is to 5. Like all of those ratios are kind of like jammed together into one. Okay, that's called an extended ratio. So we're going to treat that similarly to how we did the triangle problem up above that had the x in it. Okay, I need an equation. So this time we're going to do 3x. And again, this is not a guess and check problem. This is an algebra problem. 3x, 4x, 5x, and 6x. What should that add up to? 3x plus 4x plus 5x plus 6x. What should that add up to?
360.
360, right? It's not a triangle this time, it's a quadrilateral. Remember that every quadrilateral always adds up to 360. So pay attention to that, because it's kind of like the problems that we did with the regular polygons, right? When you do the n minus 2 times 180, it doesn't always equal 180. If it's not a triangle, it might be 540, or might be some other value. So this is going to be 360 because it's a quadrilateral. All right, how many x's is that? Let's see. 7, 12, 18. Okay, so x would be 20. Now, when you answer the question, remember you've got to actually go and plug it back in. So 3 times 20, 4 times 20, 5 times 20, 6 times 20. So we got 60 degrees, 80 degrees, 100 degrees, 120 degrees. Now, again, you always want to do a quick check and make sure it makes sense. This is easy to see because that's 180 and this is 180, so that's going to be your 360. Okay, but there should be labels on these. So get in the habit of putting, when you're answering the questions, their word problems, always make sure you go back and read what it's asking you for. Okay, something I haven't said, but I want to make sure I do say. When you're solving a proportion, this is a watch out for this situation. If you have like 3x over, I don't know, 2 equals 4 over 7 or something, you are not allowed to do this. Because this is a proportion, right? What you are allowed to do, if you had 3x over 2 times 4/7, that's allowed. Okay, if you're multiplying here, then you're multiplying and you're saying you're taking out a factor of 2. If it's like that, then you can say, all right, I'm going to go ahead and divide out a 2 on the top and on the bottom. And then you're multiplying straight across. Okay, but this one, the way I would categorize this is do not cancel across an equal sign. You can divide over here. If it's like 8x over 2, you can make that 4x on the same side of the proportion. Okay, but do not cancel across the equal sign. There's a lot of bad algebra that happens in this chapter. So if you're good with algebra, that's awesome. If your algebra is a little weak, hopefully it gets better as we're doing more practice. Okay, but I'm looking at this and I'm just kind of thinking like, don't be trying to cancel like a 12 and a 4, for example. Okay, You also are not allowed to do this. And that's because of this subtraction sign there. Okay, whenever there's a subtraction, it makes the simplifying a little more difficult. So on this one, I would go ahead and just cross multiply. Jerron, tell me what that's going to be when you cross multiply.
4 times 3x minus 12 equals 6x.
Okay, so 12x minus what?
48.
Yeah, so again, you don't have to write this step, but it's super important that you remember to distribute. So sometimes that's a good idea to write that just to make sure that you're not going to forget to distribute. So 6x equals 48, x would be 8. All right, on your homework, you're going to see some word problems where it's like just set up a ratio. You're going to see some word problems with like the equations like this kind. You're going to see some conversions like this kind. Okay, so the homework really should be pretty straightforward, like what we were just talking about, and it's only one page. So tomorrow we will talk about more solving proportions, but we'll be reviewing factoring and quadratic formula, because sometimes with proportions, when you cross multiply, it ends up giving you a quadratic.